graphing quadratic functions from factored form. Factored form. And you have not yet seen factored form. You have, but you didn't know it was called factored form. And so you can see here, it gives you an example of factored form. Now, understand that might look a little bit weird to you, right? You're used to seeing it like this. Right? Okay. So if you'll notice on this first exercise, that's in standard form. X squared minus 6x or plus 6x minus 40 is in standard form. Guys, when we factor that, it becomes factored form. So let's factor this. There's not a greatest common factor, so I'm going to go straight to two binomials, x and x. What factors of 40 do you think I should use? 4 and 10. Okay. Which one needs to be positive? 10, because I've got that positive 6 right there I'm trying to get to. But I need to multiply, get a negative 40, so I got negative 4. And then zero product property says we set both of those equal to 0, which it already is, and we solve, right? So x plus 10 equals 0. X minus 4 equals 0. So x equals
Negative 10.
Yeah, if I subtract 10 from both sides, I get negative 10. If I add 4 to both sides, I get x equals 4. If you need to see that, sorry, if you need to see that in between step, I just subtracted 10 from both sides, added 4 to both sides. Okay. Now, that says x equals negative 10 and x equals 4. Here's the cool thing. Do you see where we had set this whole thing equal to 0? Okay, guys, that's your y value. That's your y value. So when x is negative 10, y is 0. And when x is 4, y is 0. You now have two ordered pairs. Any guesses what those ordered pairs would be on the graph? Think to yesterday. Say it again. X-intercepts. Yes. You just found the X-intercepts, guys. It's a lot easier than we thought it would be, right? And this right here is factored form. You don't have anything for A because your leading coefficient was 1, right? If we had to factor out a greatest common factor, then you'd have some number in front of that. Okay, let's keep going. Given this quadratic equation, can you find the points where the graph crosses the x-axis? Well, guys, that's what you just did, right? We said it's negative 10, 0, and 4, 0. No, that's the same. That's the same equation. That's the same one as up there. It scared me for a second. Okay. In the last lesson, we learned about the symmetrical nature of the graph of the quadratic function. How can we use that information to find the vertex? Okay, guys, the vertex is going to be halfway in between your x-intercepts, right? If I have a graph and I got some x-intercepts, your vertex is going to be halfway between those. All right, so let's see. If I want to find halfway between these 2 points, what could I do? Okay, that's one way I could do it. But if I want to calculate it without the graph, if I want to find the halfway distance between 2 points, what do I do with the points? Add them together and divide by 2. All right, so let's add negative 10 plus 4, and then we're going to divide by 2. What's negative 10 plus 4? Negative 6. What's negative 6 divided by 2? Negative 3. Okay, now a vertex has 2 points, right? Okay, this would be the x value because we used our x values. Okay, guys, to find the y value, they've given us an equation to use. Do you see it says y equals x squared plus 6x minus 40? Okay. If I'm telling you the x value of the vertex, we can substitute that in and solve for the y value. Y equals x squared plus 6x minus 40. I can substitute this in anywhere I see an x, and I can solve for y. Let's try that. Y would be -3 squared plus 6 times -3 minus 40. I put the parentheses around the -3. That way I know it's -3 squared, not 3 squared, and then take the negative. Can y'all do that on your calculator? Be careful of that -3. Remember, the calculator will lie if you don't use the parentheses. -49, is that what everybody else got? Okay, so if the vertex is at x equals -3 and y equals -49, then as an ordered pair, that would be -3, comma, -49. Okay, did you put your -3 in parentheses before you squared it? No. That's fine. If you don't put it in parentheses, the calculator goes 3 squared, and then what's the negative of that? And instead of saying -3 squared. All right, so we've got our x-intercepts. Again, I'm just going to write this here so we know what we're doing. We got our x-intercepts. We have our vertex. Y-intercept. As the y-intercept is where the graph crosses the y-axis and x equals 0. X equals 0. So how could I find the y-intercept where x is 0? Yeah, substitute 0 in the original anywhere I see an x. So that would be 0 squared plus 6 times 0 minus 40. I don't think we need a calculator for that, do we? 0 squared is 0, 6 times 0 is 0. 0 plus 0 minus 40 is -40. And as an ordered pair, that would be 0, comma, -40. That's my y-intercept. I've never heard a train whistle in this building.
I heard one the other day during track.
Did you?
I heard one while I was taking a shower. Sorry, that was random, but like
It was.
like a few days ago.
It's fine. Like, I didn't know that there were train tracks this close to the school. Okay.
Oh yeah, it's like right over by the.
Oh, on Boone Road.
Yeah.
Okay.
They just barely ever come through.
Yeah,
Not
probably.
like, but like. Fucking like, fitting, Brian.
Train. Yeah, we're all the, yeah. All right. So to recap, we found our x-intercepts, we found our vertex, we found our y-intercepts. Okay, we did a lot there. So why don't we go to the sheet I made for you, and let's fill in how we did that to make it a little easier for you guys next time, so you have something to look at. All right, how to find key features of quadratics. To find x-intercepts, if factoring the two binomials, factor the equation and set each binomial equal to 0, then solve. We're going to factor, set each binomial equal to 0, then solve. That's pretty easy, right? To find the y-intercepts, substitute 0 in for the x values and solve for y. This means you will have a point that is 0, comma, y. Well, y is the y-intercept. A lot of y's. Okay. To find the vertex, add the two x values and divide by 2. This gives you the x value of the vertex. Then substitute the x value into the original quadratic function to get the y value. To find the equation of the axis of symmetry, the equation is simply x equals blank, where the number in the blank is the x value of your vertex. And then finally, everybody's favorite, in behavior. In behavior describes what happens at the end of your graph. It is often stated like this: as x increases or decreases, you're going to pick one depending on what's happening. As x increases or decreases, then y increases or decreases. I ran out of room. Sure. As long as you know that doesn't mean divide. Domain are all the possible what values? Good. All the possible x values, and range are all the possible y values. Do not lose this sheet. This sheet is very valuable to you, right? It's a step-by-step how to find every one of those things, right? Awesome. Let's go back to lesson 9. Turn a page. I'm not worried about D and E. We can skip D and E. Go down to exercise 1. Exercise 1. Graph the following functions, then identify key features of the graph. All right, guys, in order to graph something, these are the things I want you to be able to find. Okay. Your X-intercepts, your Y-intercepts, your vertex, yeah, we'll start there. Stop and think what I was doing. X-intercepts, Y-intercepts, and vertex. All right, my cheat sheet says if I need to factor, I factor. If I look at part A, it's already factored, right? Okay, so I'm going to set each part of that equal to 0 and solve. Now, that negative in front, guys, if you need to put a 1 right there to understand that means -1, that's fine. So -1 equals 0. X plus 2 equals 0. X minus 5 equals 0. I said each part equal to 0, right? X minus -1 equals 0. That's a nonsense answer. We ignore it. If X plus 2 equals 0, what does X equal? -2. And what else does X equal? 5. Positive 5, right? Okay. So now we have X-intercepts. -2, 0, 5, 0. Those are my X-intercepts. Okay, how do I find the Y-intercept? Did you have a question?
So Whenever it's like +2, why do you change it to negative? Like that?
Because when I solve, I have to subtract 2 from each side. That leaves me with x equals -2. Yeah, generally, whatever it is, it's the opposite when you solve. Okay, so to find my y-intercept, tell me again. I replaced the x's with 0. So here we go. Y equals negative, you can put a 1 there if you want to, times 0 plus 2 times 0 minus 5. Whoa, 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 whoa. No, because I'm just substituting in to this equation. I'm substituting 0 in for x. Okay, let's solve that. So what's 0 plus 2? Yeah, that wasn't a trick question. -1 times 2 times 0 minus 5. Okay, what's -1 times 2?
-2.
What's -2 times -5? Positive what? 10. So my y-intercept is at 0, 10. Yes.
So why did that? Why you multiply it by like?
Because it's multiplication, they're in parentheses. So I did -1 times 2, which is -2. -2 times -5 is +10. Okay. So I got my y-intercept. Now we need to find our vertex. Yes. I did -1 times 2, which is -2. I'm multiplying left to right. -1 times 2 is -2. -2 times -5 is +10. Yeah. Okay. You can multiply in another order. 2 times -5 is -10 times -1 is +10. I mean, doesn't matter what order you multiply in. You're still going to get a +10. Okay. For our vertex, we take the 2 x values of the x-intercepts, add them together, divide by 2. So -2 plus 5 is 3, and 3 divided by 2 is, okay, y'all wanted to go that way, 1.5. Okay. That's the x value. All right. Once I know any x value, guys, I can go back to the original equation and substitute it in and find the y value that goes with it, right? So go back to your original equation up here. So I'd have -1 times 1.5 plus 2 times 1.5 minus 5. You could, yeah, that's probably what I would do. But if you're afraid of fractions, then you can change it to a decimal. Fractions are friends, not fear. All right, here we go. 1.5 plus 2 is 3.5, right? So -1 times 3.5 times 1.5 minus 5 is -3.5. -1 times 3.5 is -3.5. -3.5 times -3.5 is 12.25.
What about in like fractions? I was doing fractions. Now I'm confused.
It would be 12 1/4 or 25 fourths, I think, in my head. 12, let's see, 12 1/4 would be,
Why is it in four?
because 0.25 is 1/4. 1/4.
But we started in that.
I know.
So why is it in four?
Use your calculator. Do -3.5 times -3.5. What do you get?
12.25.
which is 12 and 1/4.
I still, I need to know the ones in the parentheses, so like 3.5.
Oh, okay, I got you. So 3.5 as a fraction would be 7/2. Sorry, I was not on the same line as you, Claire. I apologize. So 7/2 times 7/2 is 14/4. No, 49/4.
13. 4. I don't know.
Right, 7/2 times 7/2. 7 times 7 is 49. 2 times 2 is 4.
Oh, no, because I just put 12 back in.
There you go. Okay. Guys, when you are graphing, sometimes it's much easier to see it in decimals and fractions. So, I mean, I'm not upset that you changed it. All right. So that means our vertex is at 1.5, comma, 12.25. Phew, that's a lot, right? All right, so I want to graph this, but listen before you draw your axis on the graph. Okay, we have to go up to 12.25. Okay, I don't have any negatives for y, so I definitely want to draw my axis. Oops. I don't want to draw my x-axis through the middle. I want to draw it down some. So I have room to count up. Does that make sense? So x, y. And I'm going to go by ones. Okay. The first thing I want to put on here are my X-intercepts. So I had an X-intercept at -2, 0. Had an X-intercept at 5, 0. So I'll put those 2 points on. Kind of hard to see the pink on top of the red. Let me. I'll switch to blue. Okay. The next point I want to put on is my Y-intercept. That's at 0, 10. Right up there. Then I want to go put my vertex on. And we said that's at 1.5 and 12.25, which is a really kind of hard thing to graph, but right about there. Just above the 12. Now, I could probably graph it at this point and get pretty close, right? But it helps if I had one more point on that right side. Can you kind of see why that would help? Okay, so here's what I want you to look at. We know that a graph is symmetrical, yes? Okay, and we know our axis of symmetry is right about here, 1.5. Yes? Okay. My question for you, how far is this y-intercept from this axis of symmetry? How many units? 1.5, right? So 1.5 to the other side, I should have another point there, right? So let's go 1.5 to the other side on the same level, the same y, right? and put a point right there. Because we know symmetry. At that point, it's a little bit easier. I'm not saying it's perfect, but it'll be a little bit easier to graph. And my quadratics always look like they have a cone head at the top, but that's just because I can't draw. Something kind of like that. Let's see if I can make that a little better. That's a little better, maybe. Your graph would look something like that. That's the, yes. Oh, yeah. Yeah, oh no, that's why this is the last new thing we're gonna learn. We're gonna practice this next couple of days. You're okay. I got you.